In this lesson, we're going to be looking at how to work out the purpose of a given algorithm and explain that in an exam. We're also going to be looking at standard methods of solutions, and these are limited to linear searches, bubble sorts, totaling, counting, finding the max, min, and average value. In most exams for paper 2, these are the only solutions that they will be testing you on. They'll probably be phrasing the questions differently, so they sound different. However, the techniques are going to be the same. So if you understand these techniques, you're not going to have any difficulty tackling paper 2. Okay, let's begin by finding the purpose of an algorithm. How do we do that? Well, most of the time, algorithm is just a sequence of steps, and you can use a trace table to work out what the purpose of an algorithm is, because sometimes algorithms can become very complex and you can't really see what the purpose is. I'll give an example. If I have an algorithm that says input number one, input number two, total equals number one plus number two, output total. That's fairly easy to work out the purpose. It's just adding two numbers and outputting the results. But when you have significant number of steps, loops, selections, it becomes quite tricky. So a trace table comes in handy here. You can follow the algorithm step by step, and you can see what happens to the values, variables, and so on, what changes are made when these are made. And this helps you determine the purpose of an algorithm, because once you go through that algorithm, the trace table will show you what's happening to the values, and then you can make an intelligent decision about the purpose. So let's look at how the process works. On screen, you see an algorithm. Describe the processes in this algorithm and state its purpose. This could be a typical exam question. So let's look at what's going on. We've got an algorithm where you input three values. Then we look at if value 1 is greater than value 2 and value 1 is greater than value 3, we output value 1, and then we do some more comparisons, and then we finally output value 1 plus value 2 plus value 3. Now, this is a simple algorithm, and most of you probably guessed what the purpose is. But if you were doing it in a trace table, we would then look at value 1, value 2, and value 3 in the trace table and the output. We will then use some test data, basically a set of numbers in this case. For example, we used 1 for value 1, 2 for value 2, and 3 for value 3. We'll then follow the logic in the algorithm and list the output in the output column. We can then repeat the process with another set of test data to verify if our initial decision was correct. And that helps you decide the purpose. Now, this algorithm is pretty straightforward. It just simply works out the highest value out of the three and then outputs the total of the three values. Now, when you're describing an algorithm, you need to do more than repeat the lines of code using English. For example, for line 2 below, which is assigned the value 0 to x, you can't write it is a for loop where y is 0 to x. This is stating what the code is. It's not really describing the algorithm. Now, if you wanted to work out the purpose of the algorithm, there's normally three parts. You've got the input, then you've got the processing, which is the loops, and then you've got the output. So in our algorithm, a number is being input, there's a loop occurring, and then we're outputting the values which are part of that particular loop. For example, the loop runs from 0 to x. So if the input was 5, it would run from 0 to 5. So the output would be 0, 1, 2, 3, 4, 5. Now, from this, you can develop a description of the algorithm that the algorithm takes a number from the user and then outputs all the numbers from 0 to whatever the number the user inputs. And this question normally comes after a trace table question in the exam anyway. So you will have to do a trace table exercise, and then you'll be asked to define the purpose of that algorithm. Okay, let's move on to standard methods of solutions. Now, these are standard algorithms that are used to solve problems. For example, searching, sorting, totaling, counting, and working out max, min, and average values. These are some common solutions that we use in most programs. So a search algorithm normally checks a set of data to identify whether a specific value exists in the data or not. And one example of this is linear search, and you will need to know this algorithm for the exam. And we'll look at that in a moment. A sorting algorithm takes a set of data and rearranges it to be in a specific order. For example, ascending or descending, alphabetical order, or Z to A. And one example of this is bubble sort. Totaling is basically addition. Counting is working out how many numbers occur or how many steps are taken. And max, min, and average are pretty straightforward mathematics operations, and you should be familiar with them. Let's start by looking at linear search. In a program, you might need to look for a specific value in a set of data. A linear search will check each item one at a time, starting with the first item and continuing until it either finds it or it checks the last item and reports that the item wasn't found. Now on screen you see a bit of pseudocode that shows you how a linear search will work with an array. You get an array which is assigned a set of values, so those numbers are there. We're going to set an array index and we're going to make sure that it runs from the first position to the length of the array. So if you look at the array has 1, 2, 3, 4 items. So this will run from 1 to 4. We then use a selection where we say if in the array at that particular array index, so array position 1, if that equals the search value, then you output that we found the item at that location. Otherwise, we end the selection and we move on to the next index. So if you're looking for 189, we'll check the first position. Is that 189? No. We update the index to the second position. We check that. Is that 189? No, it's not. Then we check it again at the third position. Is it 189? Yes, it is. Then we output found at 3. Now this algorithm is inefficient because if it finds the search value, it will still continue running until it reaches the end of that array. Now this is very useful to know if you want to find multiple values. For example, if 189 was occurring 100 times in an array which had a million items, then you might want to find all of the instances of 189. However, if you just wanted the first one, it becomes very inefficient because you want the loop to stop when the item is found. So you can make the algorithm more efficient by using a flag, which allows you to exit the loop once an item is found. Now on screen is a modified example of the linear search algorithm, and this is an efficient version of the previous algorithm. So do pause the video and study this. We've got an array with some values. We set a found flag to false. This flag is a Boolean flag which will be used to stop the loop. And we set the array index to position 1 because we want to start searching from the first position. And instead of using a for loop, because we don't know when we're going to find the item, so we're going to use a while loop instead. So we're going to say while found equals false, because it is false at the moment, we haven't found the item, and the array index is less than the length of the array. So we're going to start with position 1, and then we're going to iterate through all the positions until we reach the length of the array, which in this case is 4, because there are 4 items. We'll then do our selection if array and the value at that array index. We use that square bracket notation in pseudocode. We'll look at that later as well when we discuss pseudocode in Unit 8. If the value at that position equals the search value, then we output found at index 1, index 2, whatever. We then set the found flag to true. Remember, the while loop is saying keep running until the found loop is false and the array index is less than the length of the array. So the moment we set this found to true, we can exit the loop straight away instead of going through the rest of the values. If we haven't found the item, then we can use an else command to simply increment the array. So we say array index is equal to array index plus 1, and then we finish off our end if and our end while. Now, this is a much more efficient way of doing a linear search, and chances are that in an exam you'll be asked to make an existing linear search more efficient, and you make it more efficient by exiting the loop as soon as you found the item. Okay, let's move on to sorting. Sometimes you may need to sort a set of data into specific order, for example, ascending numerical or descending alphabetical. And one method of sorting data is using a bubble sort. There's quite a lot of different sorting algorithms out there like quick sort, merge sort, and insertion sort. However, we're not going to be looking at that. For the purposes of our syllabus, we only concentrate on bubble sort. Now, bubble sort takes the first 2 values in a list and compares them. If they're the wrong way around, for example, if we were looking at ascending numerical order, we want to check if the lowest value is on the left and the highest value is on the right. So we compare the values, and if we found that the highest value is on the left hand side, we need to swap them. And then we continue doing this for the rest of the values all the way through the list. Now, once we've done one pass of the list, we have to start again and compare the first 2 values to make sure they're in the right order, and we keep doing it until there are no more swaps that occur in that particular list. So it's called bubble sort because it acts like a bubble moving across all the elements to the end of the list. So you start from the beginning and you keep swapping, and the bigger item is just bubbling towards the end, and then we keep doing it all over again. So eventually all the bigger items will just move towards the right hand side of the list. Now there are 2 ways to tell the algorithm when to stop. The algorithm has to go through the entire list, which is the number of elements in the list minus one. Why minus one? Because if there were 10 elements in the list, you're going to do 9 comparisons because you're comparing two values. If you get to the 10th item, there is no 11th item to compare with, so the program will crash. So if there are 100 elements, the algorithm runs 99 times. And this is the easiest way to program, but it's not very efficient because all the elements might already be in the correct order, but you still go through the list 99 times, and that wastes a lot of processing time. So either the algorithm has to run through the list minus one times, so whatever the length of the list is, minus one, or it has to run through the list, checking all the elements and finding out if it's made any swaps. So it then needs to use a flag, just like we need to use a flag in the linear search to make it more efficient. So if we go through the entire list and we haven't swapped anything, the flag says no swaps equals true. Therefore, we exit the loop. That makes it much more efficient. Now on screen, you see two examples of bubble sorts. There are many different ways to bubble sort, and these algorithms that you see on screen will work both with numbers and text. So the first algorithm is very simple, it's inefficient, but easy to remember. It runs for a fixed number of passes, which equal to the length of the array minus one. It then uses an inner for loop to go through the array and compares each element with the next one. So you look at position one and compare it to the second one. And if the current element is greater than the next, it swaps them. And this continues until the loop has iterated or gone through the array enough times, ensuring that by the end of all the passes, the array is sorted. The outer loop controls the number of passes, while the inner loop goes through the array and performs the comparisons. And we do the swap by introducing a temp variable to temporarily store the value of one of the indexes, so we can copy it there and paste it back in as required. Now, the second algorithm is much more efficient and it compares the elements and swaps them if necessary, but it introduces a flag, in our case, the changes flag, to check if any swaps were made during a pass. It continues to run until no changes are made in a complete pass. So if the list was already sorted, it will go through the entire list, it will do one pass, and the changes flag will not change, which means that you can exit the loop after one pass, which makes it much more efficient because that indicates that the array is already sorted. If a change is made, then the changes flag is set to true and the loop continues again, and it keeps doing it until the changes flag remains false. The outer while loop ensures that the process stops early on when no more swaps are needed, making this version much more efficient by avoiding unnecessary passes. So do pause the video and compare both algorithms. You should be able to see how a flag can make an algorithm more efficient. Okay, that's enough about sorting. Let's move on to totaling. Totaling is easy. It's just adding a group of values together to give a total. You might have 10 values in an array and you might need to output the total for that. Or you might want the user to input values and add them all up and output the total. But whatever you want to do, the process is that you're going to initialize a total variable and set it to 0, because at the beginning the total will be 0. And then you add the value that you want from either the array or from the input to this variable. Then we assign total plus value to the variable total. So if the total was 0 and the first value was 50 cents, then we add 0 plus 50 cents and total becomes 50 cents. And we keep doing that in a loop. So on screen, you see two examples. Do pause the video and go through those. They're pretty easy to understand. In both, we assign the total value to 0. So for total and total value, the initial value is 0. We then do a loop. In this case, we're inputting 10 values or going through the length of the array. And then we either input the number or we just simply add the value, add that array's index to the total variables. And then finally, outside the loop, we output the value. And that's all there is to totaling. Let's move on to counting. Now, counting is working out how many of something there are. And for example, counting how many fingers you have or counting how many items you bought when you went shopping. And just like totaling, we have to initialize a variable at the start. So the count variable is set to 0. And then we increment or we decrease the count depending on which direction we want to go. Again, on screen, there are two examples which work exactly the same way. Pause the video and study these. They should be very easy to understand. The next method of solution is minimum, and this is used to work out the minimum value in a group of values. Now, to do this, just like the other ones, you have to initialize a minimum variable, but you've got to set this to a large value, because what we're going to do is we're going to compare all the other values to this large value, and if it's smaller than that large value, then that value becomes the minimum, and we keep doing that. Now, on screen, there are two examples of this. In both of them, we've initialized minimum to a very big number, and then we just go through a loop and we keep comparing the values that are either input or are in the array to this large number. And if it's smaller than this large number, then that value becomes the minimum. And that's all there is to minimum. Now, maximum works exactly the same way, but in this case, we initialize the maximum variable and we assign it to a very small value. Because once we compare the input values or the values in an array, if that value is bigger than this small maximum, then that value becomes the max. And we keep doing that for the rest of the values in a group. If you look at both examples, you'll probably see that maximum is initialized to a very small value, in this case 0, and then we go through a loop. In the first example, we input a number, and if that number is greater than the maximum, then maximum becomes that number. And same happens in example 2, where we go through a list of items in an array, and then we compare that to the maximum, and if they're greater than the maximum, then that number becomes the maximum. Average is another straightforward mathematical operation. This normally refers to the mean. So we total all the values and then we divide it by how many numbers or how many values there are. So average is generally a combination of total and count. So what you normally do is you total all the values there are in a set, and for each value that you're adding to the total, you simply increment the count by 1. And then once the loop is finished and you totaled everything and you counted how many values there were, you can then output total divided by count to work out what the average is. Now there are two examples on screen. Both of them initialize count and total to 0 and then go through a loop. Once the loop finishes and the final values of total and count are done, we can then do an output statement which outputs total divided by count. Hopefully you've understood the standard method of solutions and you can work out the purpose of a given algorithm. On screen, there are a few questions that you should go through. You should be able to explain how you would work out the purpose of an algorithm. You should be able to define what the standard methods of solutions are. You should be able to describe how linear search works, how bubble sort works, and you should be able to create basic algorithms like inputting 100 numbers and outputting the smallest and largest value. You should also be able to explain the difference between totaling and counting. And of course, you should be able to use both of these to work out an average. That's all there is to this lesson. If you do have any questions, please do get back to me. Otherwise, I'll see you in the next one.